So good morning all. Today we'll start with the manufacturing technology. What is the manufacturing technology 1? Okay. Outline of the course will be later uploaded. So what is that manufacturing? First we Naniwala, what is your question? You raise your hand. So first starting with the what is manufacturing. We are reading the manufacturing technology. So manufacturing, what is that manufacturing? The meaning of what is the meaning of that manufacturing? Manufacturing means the making of goods or articles and providing service to meet the needs of mankind. Making of goods or articles and providing service to meet the needs of the mankind. That is manufacturing. Am I audible? Am I audible or not?
Yes, sir.
Okay. So there is some internet issues.
Yes, sir.
Yes, sir. Audible.
My screen is visible to you? Screen is visible? Screen is visible or not?
No, sir.
No, sir.
No, sir.
No, sir.
Okay.
No, sir. No, sir. No, sir.
Now visible? Now visible or not?
Yes, sir.
Now
Now
my
it's
screen
Yes, sir.
Okay, thank you. So, let's see what is then manufacturing process. I have to turn off my video, so there is network issues with here. So, okay. So see here, what is that manufacturing? The manufacturing means making of goods or articles and providing services to meet the needs of mankind. Making of goods or articles, making of goods or articles and providing service to meet the needs of mankind. That is your manufacturing. The manufacturing process means that part of the production process which is directly concerned with the change of form or dimension of the part being produced. Manufacturing process means the steps or the processes involved for the finished product. That means manufacturing means we are going to manufacture a process or manufacture a goods or an article. So what is the process involved for the production of the that article is known as the manufacturing process, or the article or the goods that is called as the manufacturing process. First is the manufacturing. First you have to understand what is the manufacturing. Basically implies the making of goods or articles and providing services to meet the needs of the mankind. That does not mean we are manufacturing anything. That articles or goods, they're providing services to meet the needs of the mankind. If that goods or articles is not providing any services to the mankind, so that is no meaning. That product has meaningless. So we have to produce or the manufacture or the production of the some parts of the goods or the articles that providing services to meet the needs of the mankind. So process means here the manufacturing process means the steps or the processes, production process, that is generally called all the production processes involved with the goods or the articles for the manufacturing. That is your manufacturing process. See next. Okay. What is the evolution of the manufacturing started? The evolution of the manufacturing started about generally 5000 to 4000 BC. With the production of various articles of goods, ceramic, stone and metals. You read also in your elementary education that there is a stone age, there is a iron age. That means there are the peoples are having the skills before that. They have the skills for the production of the different parts, like your stone age, iron age. That means. So derived from the what does the manufacturing means? That is derived from the Latin word that is manu and factors. Manu and factors means made by hand. Made by hand. Manufacturing means that is derived from the Latin word. One is the manu and other is the factors. That means made by hand. Manufacturing. The word manufacturing first appeared in 1567. The year 1567 that manufacturing word is first invented. Then word manufacturing appeared in 1683. And appeared in the general manufacturing process that is in 1683. Production is also used interchangeably. In case of manufacturing, there is also we can use the for production also. So there is just some sound. So please mute all. Okay. Please mute all. So what are the manufacturing processes? See here, what are the manufacturing processes? The flow diagram shows you the different manufacturing processes. If you are making the note from this slide, if you have difficulty in writing in the particular slide, you can tell me to write there. Okay, I am waiting there for you to write the total whatever you needs there. So if there is any problem, you can ask me at that moment. So what are the manufacturing processes? Manufacturing process involved here is that there is a process here, materials modifying process. Another thing is the joining process. Manufacturing process is basically divided into two categories. That is called as material modifying process, or there is the joining process. Modifying process means we are making you giving the shape of the material by the either material removal process or by deformation process or the shape change, or you can say by the process of metal addition. That is the current trend in mechanical engineering in the additive manufacturing. So these are the manufacturing processes. Another is the joining process. Joining process, you can see the welding processes, soldering, riveting, bolting. These are the joining processes. In materials modifying processes, we have additive manufacturing, subtractive manufacturing, or the plastic deformation in the materials. So in materials modifying process, that what we do here, that we are going for the property modifying, and shape modifying. There are two modifications. One is the property modification, then is the shape modification. Property modification is done by the heat treatment process and surface treatment process. If you read the heat treatment in your last semester, then you can understand what is how the property will be modified during the heat treatment process, then the surface treatments. Then the shape modifying, another modifying process in metals modifying process is the shape modifying process. Shape modifying has three categories generally. As I have told you, the material removal process, material addition process, material retention process. That is, material retention means constant volume process. Here the material removal process means as you have done in your workshop, in a lathe, milling or shaping machine, that is the making of the jobs in these processes are the material removal process. That means we are giving the shape to the particular material. We are giving the shape to the particular material by metal removal. We are removing the metal from that job. That is the metal removal process. Materials addition process means that is called the additive manufacturing, which is used currently in the mechanical engineering. The current hot topic is the additive manufacturing. In additive manufacturing, the hot topic is the 3D printing. Okay, in 3D printing we can print any shape. In three-dimensional printing, we can print any shape. You can search to the Google what are the parts made by the 3D printing. From a building to the ship building to the submarine building. Submarines are also built by the 3D printings. So another is the metal retention process. Here the plastic deformation process is there. Here is the plastic deformation process is there. That is the metal retention process. And this is about the metals modifying process. If you see the metal joining process has two categories. One is the permanent joining process, non-permanent joining process, and semi-permanent joining process. In permanent process, the welding, soldering is the permanent joining process. Non-permanent is the and the riveting also a permanent joining process. Non-permanent has the your bolting. These are the non-permanent. and there is also the semi-permanent joints are also there. So this is about, this slide is about all about the manufacturing processes involved. So what will we read there? We'll read, from this we'll read the one of the manufacturing processes involving here. So in we are not firstly we are going for the materials modifying process. Second we are going for the joining process. Both the processes we will read here. In the MT1 both the processes are here. So we'll first starting with the materials modifying process. Now, what are the traditional manufacturing methods? Then traditional manufacturing process we have the casting, forming, sheet metal processing, plastic processing, joining, and the lathe. So here casting is the one of the oldest technique of materials modifying process. The most oldest materials modifying process is the casting, and these are the jobs made by, these are the products made by the castings. From a very complicated shapes that can also be modified, that can manufactured by the casting process. This is a V engine block, V-shape engine block. This is the engine. This is the this is one of the engine blocks here with the air vents. And these are different parts that is made by the castings, and these are the different parts also here that is also made by the castings. So another thing is the forming. Here we will focus on the casting only because we have in our course we are going to be study about the casting. So later we will see what are the different joining, lathe, plastic processing, sheet metal, and the forming processes are there. So let's start with the process of casting. What do you mean by the casting? This is the casting. What do you mean by the casting? Casting is the manufacturing process by which a molten material such as metal or plastic is introduced into a mold, allowed to solidify within the mold, and then ejected through broken out to make a fabricated product. How many of you understand this statement? Casting is a manufacturing process by which a molten material such as metal or plastics is introduced into a mold, allowed to solidify within the mold, and then ejected or broken out to make a fabricated products. So see here, what is the definition says here? This is a manufacturing process. Casting is a manufacturing process in which molten material means the metal in its liquid state. The metal in its liquid state, that molten, that may be the metals or the plastics. Here see the term material means here both the metals and plastics we are considering. Both the metals, or if you consider the metals should be in its liquid form, and that liquid metal will be poured into a mold, that is called mold or mold cavity. That liquid metal will be poured into a mold cavity. That mold cavity is made by the patterns, that is take the shape of the patterns. That means there is a replica of the product that is to be made, and that in that mold we are after pouring the liquid metal or the liquid plastic in the mold, we are allowing it to solidify, or we are going for the solidification process. After the complete solidification or the cool down, then we have to ejected that mold or broke that mold. We are going in your lab with the foundry practice, there we have you have the making of the sand mold. So from after the molding process is completed, we have to break that sand mold to bring the metal out, bring the metal out. So this is the method of that is called as the manufacturing process. That is the called as the casting of casting is a manufacturing process. Manufacturing process means that means we are making a product. The product of the casting, the solid product, is called as the casting. The solid product that is obtained from the process, from that process, is called the casting. So casting is used to making complex shapes that would be difficult or uneconomical to make by other methods, such as cutting from solid materials. So where we are using castings, castings are generally used for the production of the complex shapes, and it is, and where also it is used if that product is very costly for manufacturing. There are two reasons why you are going for the casting. If for the complex shape, second is the uneconomical. If that product is going to be very costly by any other processes, any other manufacturing processes, then we have to switch over to the castings. So this is the reason why we are going for the casting. So first you have to clear your idea here. What is what do you mean by the casting, and why we are using casting? Why we are going for the castings? So casting since about 4000 BC. This is the castings product made about the 450 BC. See this ancient Greeks bronze that is made on 450 BC before Christ. And iron works really in Europe. Cast iron cannons from England circa that is 1543. Casting is the oldest method. Casting is the oldest method of manufacturing. Before, just about 3200 BC, copper part, a fork that is made by the casting at Mesopotamia, oldest known casting product in existence. This is the oldest known. A frog made from the copper that was cast in Mesopotamia. That is about 3200 BC. This is the oldest casting product. Then at 233 BC, cast iron plowshares in China. That is 233 BC. Then at 500 AD, cast crucible steel in India. The cast crucible steel that is made in India. That at 580. And 1642, first American iron casting at Saugus Iron Works, Lynn MA. So these are the history. These are the histories of the castings during the different times. So we are
Sir,
using
what is that frost cast?
uh, your question.
Sir, what is that frost cast, sir? Sir, FROGD frost cast.
Forged cast. That means we are making by the forging method.
In Mesopotamia. Yes, sir.
No, no, a frog. Forged cast, that is a frog. A frog was first cast in Mesopotamia. Frog
Yes, sir.
ବୁଝିପାରୁଛୁ ତ? ଆମେ casting ରେ
Yes, sir.
product ତିଆରି କରୁଛୁ ନା, that product
Yes,
was
sir,
a
yes.
frog. Okay. So see, the castings were
Yes, sir, got
used
it.
for the complex and 3D shapes. Castings are generally used for the production of the complex shapes. So complex shapes means near net shape, low straps. That is in casting. That is in generally the straps is minimized, a relatively quick process, intricate shapes, large hollow shapes, no limit to size, reasonable to good surface finish. So these are the complexity associated with the other manufacturing processes that cannot be achieved. But in casting processes, these complexities can be achieved, like on your net shape, low scrap. Scrap means the wastage materials. That is low scrap, relatively quick process. Process will be high, quick process. Intricate shapes that can be made here. Large hollow shapes can be made here. No limit to size it. There is no size limit. Any shape size we can made in casting if you have the particular die. So reasonable good surface finish. So surface finish can be achieved also during the different casting processes. So these are the reasons why you are choosing the casting. We'll go to the next slide. Then capabilities. And what is the capabilities of castings? So if you see the dimensions in dimension wise, so sand casting is the large as large you like dimension, small to small like 1 micro mm, and so can be made. The dimension I see the sand castings we can made here, large as large product we can cast here. The also the small parts like 1 mm size can also be made here. The tolerance means what is the limit in size. The tolerance of 0.005 inch to 0.0 inch can be maintained here. If you see the surface finish, then the die casting of 0.8 into 16 micro inches, 1 to 3 micrometer, that is 1 to 3 surface. If you read about the surface finish, then you can understand these terms. But the surface finish can be maintained up to 1 to 3 micrometers. In die casting, there are different types of castings. That is, I am mentioned here. One is the die casting, other is the sand casting. As we read, you can clear here what is the die casting, what is the sand casting. But you have to remember this just to accommodate the terms here. Like what is the die casting? Die casting surface finish is 1 to 3 micrometer, can be achieved. In sand casting that we have 2.5 to 25 micrometer can be achieved here, the surface finish level. So these are the capabilities of the casting. So dimensions can be achieved, tolerances, good tolerances can be achieved, and better surface finish can also be maintained. So these are the capabilities of the your castings. And see here what are the advantages and limitations here in castings. So advantages here is that molten metal can flow into very small sections, so that intricate shapes can be made by this process. As a result, many other operations such as machining, forging and welding can be minimized. So what is the advantages here? Advantages, the single meaning of this first statement is that so this statement says that the single meaning of this statement is that intricate shapes can be made. Intricate shapes. So how the intricate shapes will be made? Because as the in casting we are using molten metal. Molten metal means the metal in liquid form. So that can flow to any small sections of the pattern cavity, mold cavity, any small sections of the mold cavity, that liquid can flow. That's why you can achieve the complex shapes in castings. So next point is possible to cast. This is next point. The possible to cast practically any material, ferrous or non-ferrous. We can cast any material. That means ferrous or non-ferrous material can be cast here. So third point is the necessary tools required for casting mold are very simple and inexpensive. As a result, for production of the small lot, it is ideal process. So it is about the first is about the complex shapes. First point is about complex shapes. Second point about the all materials that we can use. You can cast any material. Third point is about the tools used. The tools used in casting. The tools used in casting process is very inexpensive. That means it is a very cheap process. The fourth point is there are certain parts like turbine blades made from metals and alloys that can be processed this way. Turbine blades fully casting for last machining. So turbine blades, the most complicated shape that we are using, the most important also the product is the turbine blades, single crystalline turbine blades that can be achieved through this. The complex shapes or the important products can also be made through the casting processes. The last point is about the size and weight of the product. So we have no limit of the size and weight of the product. We can make any size of any weight, weight. So there is no limitations of the size and weight. These are the 5 points of the advantages of the castings. So what is the limitations there? So here see here what are the limitations then? What are the disadvantages there? So disadvantages here is that dimensional accuracy and surface finish of the casting made by sand casting process are a limitation to the technique. When we are using for the sand casting, we are also making a sand casting in your lab. You see there is a problem with the dimensional accuracy and surface finish. There is a problem with the dimensional accuracy and surface finish of the product in sand castings. The second point is many new casting processes have been developed which can take into the consideration of the aspects of the dimensional accuracy and surface finish. Some of these processes are die casting process, investment casting process, vacuum seal molding process, and cell molding process. So to minimize this first point means the dimensional accuracy, difficulty in achieving dimensional accuracy in castings. There is the main problem, main disadvantages of the your casting. So dimensional accuracy. To minimize this process, to minimize the dimensional accuracy, to get over the dimensional accuracy, we have the different processes like die casting process, investment casting process, vacuum seal molding process, and cell molding process. In the lab, I will show you the die casting process and the vacuum seal molding process. I will show you how the better surface finish and the and your dimensional accuracy can be maintained than compared to the sand casting process. Then the next is metal casting is a labor or intensive process? Metal casting is a laborious or intensive process? When you are using the die as the metal as the die, then it will be an intensive process. Then the third point is automation. A question. Yeah, we are going for the automation process. The whole is moving towards the automation. So in automation, there is. Am I audible? Am I audible?